Okay, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. So we will continue our discussion a little bit on the Born-Haber cycle. Now, I would like to talk about the factors that can affect the magnitude of the lattice enthalpy or the lattice energy, the magnitude or the strength. Yeah. So the strength of the lattice enthalpy depends on two factors: the ionic size of the ions, the ionic size or the size of the ions, and the ionic charge, the charge on the ions. Let's look at these two examples here. So we have sodium chloride and potassium chloride. Both of these ionic compounds are made up of sodium ions and potassium ions bonded by the ionic bond to chloride ions. So the anions are the same. So the anions have the same charge, which is -1, and also the cations have the same charge, +1. So which one is stronger? Which of the compound has the greater lattice enthalpy? So sodium chloride has the greater lattice enthalpy. Why do you think? What is the reason? Okay, and let's look at lithium fluoride or magnesium fluoride. So magnesium fluoride has the greater lattice enthalpy value. Okay. Now let's look at the reason. The simple explanation to this. When we talk about ionic size, please recall what you have learned in Chemistry 1 about the trend in ionic size and the factors that affect ionic size. So now, when we're talking about magnitude of lattice enthalpy, the ionic size affects the magnitude or the strength of the lattice enthalpy by affecting the strength of the attraction between the ions. So the smaller the size of the ion, the stronger the attraction will be. Okay, therefore stronger attraction between the ions will result in a greater energy to break this attraction between the ions. So when we look at this example between sodium chloride and potassium chloride, so which of these ions, sodium ion and potassium ion, has the smaller size? Okay, try to refer to the periodic table. Okay, so you might be able to recall the reason. Okay, ionic charge. The smaller the ionic charge, the weaker the attraction. Therefore, smaller lattice enthalpy, or easier for us to break apart the ions. So please ponder upon these points, factors that affect the magnitude of lattice enthalpy, so that you will be able to explain in your own words the reasons for this observation, which is sodium chloride has a greater lattice enthalpy than potassium chloride, and magnesium fluoride has a greater lattice enthalpy than lithium fluoride. Okay, now, so another important factor that you should know in calculating enthalpy change is the bond enthalpy. So bond enthalpy is the enthalpy change required to break a particular bond in 1 mole of gaseous molecule. So basically, we are concerned with covalent bond, right? So here is the data. You can see this data also in your textbook of various bond enthalpy, yeah, and also the bond length. So bond enthalpy, this is the energy needed to break these covalent bonds. Yeah, you can see that. Let me show you an example of. Can we have? Is it carbon single bond? The bond enthalpy is 347 kilojoules per mole. Carbon double bond, 614 kilojoules per mole. So the carbon double bond is stronger than the carbon single bond, right? So more energy is needed to break the carbon double bond. There's no data for carbon triple bond here. Okay, so you can use this formula based on the bond enthalpy data to calculate enthalpy change of reaction. So the formula is the sum of the bond enthalpy of the reactants minus the sum of the bond enthalpy of the products. Okay, as an example, yeah, calculate the enthalpy of reaction for the chlorination of methane to form chloroform. So you must write the balanced chemical equation and also Lewis structure. By drawing the correct Lewis structure, you will know whether single bonds are present only, or there are also double or triple bonds present. It is very important for you to know this, so you should get the correct total bond enthalpies that are involved in the reaction. So please remember the formula. The enthalpy of reaction is equals the sum of the enthalpy of bonds broken plus the sum of enthalpy of bonds formed, or you can use this formula. It is actually the same thing but expressed in a different way. It's the bond enthalpy of reactants minus bond enthalpy of products. Okay. Okay, so we've come to the end of our discussion on thermochemistry. So I hope you have understood clearly this topic, and so you can also try these 4 questions to test your own understanding of this topic. Oh yeah, I will also do another video talking about energy cycle, how to draw energy cycle, inshallah. Okay, so thank you very much for listening to the videos. I really hope that it helps in your revision process and your understanding. So if you have any question, please feel free to ask me, or write comments in the comment section. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.